So in this video, we're going to talk about how to recognize terms and factors within rational functions. So a rational expression, remember, is a fraction that has a polynomial in the numerator and the denominator. You can see here we have some examples of rational expressions. A polynomial is made up of several terms that are combined by mathematical operations. So you can see 2x to the fourth minus 3x squared plus 2x minus 5 is a polynomial, and each of these separate monomials, 2x to the fourth, 3x squared, 2x, and 5 are terms that are within the polynomial expression. So we can simplify a polynomial by factoring. And so what the factors do is that they can be multiplied together to form the original polynomial. So 2x squared plus 6x minus 20 can be factored as 2 times x plus 5 times x minus 2. All three of these factors can be multiplied together to form the original polynomial. So here are steps to factoring polynomial. You're always going to start off by looking for a GCF and then factor it out. Then you're going to check the polynomial for any special patterns. If you see the difference of squares or perfect square trinomials, go ahead and use these patterns to factor. If not, then you're going to factor the remaining polynomial using factoring by grouping. So you'll group the first two terms and the last two terms, factor out the GCF of each set, and then factor out the common binomial. Remember, all of these steps are going to be used as needed when you're factoring a polynomial. You may use all, none, or just a few of these steps. So let's try factoring 2x plus 10. So if we look at 2x plus 10, we're going to start off looking for a GCF. Notice that 2x and 10 can both be divided by 2. So I'm going to factor out the GCF of 2, which means I'm going to pull it out in front. So what I'm going to do is I'm going to divide it out of whatever is remaining in that polynomial. Okay, so I'm going to divide every term by 2. So that 2 is going to stay in front, and then 2 and 2 cancel, leaving me with just x, and then plus 10 divided by 2, which is 5. So 2 times x plus 5 is the factored form of this polynomial. So now let's factor 2x squared plus 6x minus 8. So notice that all three of these terms have a common factor of 2. So I'm going to use that GCF of 2. I'm going to factor it out, so that leaves me with 2 times 2x squared divided by 2, and then plus 6x divided by 2, and then minus 8 divided by 2. So when I factor this out, I have 2 times here, 2 and 2 cancel, so I have x squared plus 6 divided by 2 is 3, so we have 3x, and then minus 8 divided by 2, which is 4. Now I'm going to factor that polynomial that remains. So I don't see any special patterns, so I'm going to go ahead and use factoring by grouping. So remember, what I do in factoring by grouping is I multiply a times c. So in this case, a is 1. So 1 times c is going to be negative 4. And then I'm going to look at the factors of negative 4 that are going to add up to 3. Since negative 4 is negative, I'm going to need a positive factor and a negative factor. Since 3 is positive, I'm going to make my bigger factor positive. So I'm going to factor this out, so I have 1 and 4, 2 and 2. Make the bigger factor positive, so the smaller is negative. And then negative 1 and 4 gives me the correct sum, which is 3. So that's the correct combination. So I'm going to go ahead and use this to write the factors. So I have that 2 that's still in front, and then I have x minus 1, and then I have x plus 4. And that is the fully factored form of this polynomial. Don't forget to include the GCF when you write the final factored form. That's very important. So now let's try factoring 3x squared minus 48. Once again, I'm going to start off looking for a GCF. Notice that these two terms have a GCF, which is 3. So I'm going to pull the 3 out in front and then divide everything by 3. So that leaves me with 3 times, here 3 and 3 cancel, so I have x squared minus 48 divided by 3, which is 16. Well, now I have x squared minus 16. Notice that this is one of those special patterns, right? I have two perfect squares. So remember, a squared minus b squared equals a plus b times a minus b. Right, this x squared minus 16, that is basically like x squared minus 4 squared. So my two perfect squares. So I can write the factors as x plus 4 and then x minus 4. Don't forget, in the final form, I also need to include my GCF, which is 3. So this is the fully factored form of this polynomial. Now let's factor 3x squared minus 10x plus 8. So I look at these three terms. I don't see a GCF that I can factor out. There's no common factor of 3, 10, and 8. So I don't see any special patterns, so I'm going to go ahead and factor by grouping. So remember, this is A and this is C. So A times C gives me positive 24. So since I have a positive number, I either have two positive factors or two negative factors. Well, my B term is negative, so I'm going to have two negative factors. So let's list out the factors of 24 and make all the values negative. So we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So when we add these factors, we have negative 1, negative 24, so that's negative 25. Negative 2 and negative 12, it's negative 14. Negative 3 and negative 8 is negative 11, and negative 4 and negative 6 is negative 10. So negative 4 and negative 6 are my correct combination. So now I'm going to factor by grouping. So that means I'm going to rewrite this as 3x squared minus 6x minus 4x plus 8, right? So all I did was write these two factors. I used that to rewrite the negative 10x. Negative 10x became negative 6x minus 4x. So now I'm going to put my factors into two groups. So I have 3x squared minus 6x plus negative 4x plus 8. So now I'm going to look at the GCF of each group separately. Okay, so first let's look at the 3x squared and the minus 6x. So what can I factor out of these two terms? So I can factor a 3, and I can also factor an x out of both terms, right? Because both terms have an x in them. So what I'm going to do is I'm going to divide that from both of those terms. I'm going to divide out a 3x. So when I do that, that leaves me with a 3x in front, and then 3 and 3 cancel. X squared over x is just x. And then I have minus 6 over 3 is 2, and then x and x cancel. And then now let's look at our next set. So we have our negative 4x plus 8. So what can we factor out of both of these terms? Well, we can factor a 4, but since the leading term has a negative, so I'm just going to go ahead and factor that negative out along with it. Okay, so I'm going to pull out a negative 4. So that leaves me with negative 4. We divide both terms by negative 4. And so I have plus negative 4 times, okay, negative 4 or negative 4 cancel, leaving me with just x. And then I have plus 8 over negative 4, so that's going to be minus 2. So that is 3x times x minus 2 plus negative, so it's just minus 4 times x minus 2. I'm going to pull out this common factor of x minus 2. So that's my first factor, and then I have this 3x minus 4 that remains. So 3x minus 4. So that is my factored form of this polynomial. I did not have a GCF that I need to add in, so that is the final factored expression. So now you can go ahead and pause the video and try this example on your own. So in this example, notice that all three terms have a GCF of 2, so I started off dividing out that 2. So when I divide 2, I have 2x squared minus 7x minus 4, which I can factor by grouping. So I first multiplied a and c, which gave me negative 8. Since 8 is negative, I know that I need a positive factor and a negative factor. Since 7 is negative, I needed the bigger factor to be negative, so the correct combination was 1 and negative 8. So I rewrote this polynomial as 2x squared minus 8x plus 1x minus 4. From the first group, I factored out a 2x, and then from the second group, they had no common factors, so I just factored out a 1. So when I simplified this, I got 2x times x minus 4 plus 1 times x minus 4, which gave me the factors 2x plus 1 and x minus 4. I also needed to add in the 2, which was the GCF that I originally factored out. So in summary, you can simplify rational expressions by factoring the numerator and denominator and then canceling any common factors. We're going to see this a little bit more throughout the lessons in this unit. Remember, these are the steps to factoring polynomials. You're going to look for a GCF, check for special patterns, and then factor the remaining polynomial using factoring by grouping.